Assalamu alaikum wa rahmatullahi wa barakatuhu. So today, this is Miss Asma and we're going to learn science, obviously. So, as you know, we were in the chemistry section of matter, structure of matter, chapter 3. So, to do a quick revision, what we saw was, first thing, what is a matter. So when you know, first thing is what is a matter. Matter is any substance that take up space, and matter is divided into two, such as pure substances and mixtures. Then we were talking about pure substances which has elements, right? So when you talk about elements, you have a lot of, almost around 120 elements now, and elements are made up of atoms. So atoms are tiny particles which can be divided into three other subatomic particles known as electrons, protons and neutrons. And then we saw the structure of an atom, right? So when you talk about the structure, you have the nucleus, and then you have orbits around it. So in the nucleus you have the electrons and in the nucleus you have protons and neutrons. Protons are positively charged, neutrons are chargeless. And then around the orbits you have electrons, which is negatively charged. Right. Now these energy levels or orbits are named. You know that they are named either K, L, M, N, or you can just name it by numbers. So these have maximum number of electrons that they can have, which was, we saw in K, it was only 2, which was the first one. So in the first energy level you can have only 2, so that is K. Then when you talk about L has 8 electrons, so that would be this way, right? 8 electrons. And then you have M with 18, but we told that even though it has maximum number of 18 electrons that it could fit in, it still only fits in 8. Alright, so that is KLM. And then you have N. N has 32. But since we are studying only 20 elements, we will need not to go into this energy level except for the last 2, which will have only 1 and 2 electrons in the last energy shell. So because of that, though it has 32, we will learn that it will have only 1 and 2, which is calcium and potassium. Atomic numbers 19 potassium is atomic number 19 and calcium is atomic number 20. Right. Then, oops, sorry. Then, God. Okay, so then we have stuff, so we know, so that is the structure of an atom, right? So then we saw about what a matter is, then we came across elements, and then atoms, then under atoms you have atomic structure. Now we're going to talk about atomic number, which has the symbol of Z. Okay, so what atomic number is, you know, we learned elements from 1 to 20 in the order hydrogen, helium. Yeah, we know that. So it is known as the number of protons which is equal to the number of electrons. Okay, so let's say if an element X has 11 protons, then its atomic number is also 11, and its number of electron is also 11. So number of protons equals the number of electrons is equal to the atomic number. Okay, so that is atomic number. Then you have mass number. What is mass number? Okay, remember guys, I told you all that the mass of an atom is given by the nucleus, because electrons are so light. Remember the comparisons, over 1/1840 times smaller than a proton or a neutron. So the mass of an atom is given by the proton and the neutron. So therefore the mass number is the number of protons plus neutrons together. Okay, so that is mass number. Alright, so then when you take a symbol, let's take element X, the mass number comes on top. This is the symbolic representation of elements, and the atomic number comes below. So this will be protons plus neutrons. This will be protons slash electrons, because in the elemental state they are same. Okay, so that is that. Then you have electronic configuration, right? What is electronic configuration? So we saw that elements, when you take it around 1 to 20, the first element, which is hydrogen, has atomic number 1. We learned all the 20 elements, and the first element is hydrogen. So hydrogen is atomic number 1 and its configuration is 1. So let's take an element which has the atomic number 15. So your electronic configuration, how will you write it? It is the way the number of electrons are arranged in each energy levels, KLM. Remember? So remember, we have 15 atomic number means it has 15 electrons. So if it has 15 electrons, electronic configuration is about how the electrons are arranged in the energy levels. So the first energy level will be 2, right? Because we learned previously that the electronic configuration, the maximum number of electrons in the first energy level is 2. So 2. Then we have 8. So 2 plus 8 is 10. So 10 electrons gone out of the 15. So we have 5, and the maximum number of electrons that could be there in the third energy level is 8, and we only have 5. So we can put it 5, right? Right. KLM. So 2 in K, 8 in L, and 5 in. That is how you do the electronic configuration. Next is so we learned about all of these electronic configuration. We wrote about electronic configuration of each and every element, and then we drew the structures. We wrote about how many protons are there, neutrons are there, and all. I hope you all remember that it's all interconnected, how we found one out of the other, because mass number is equal to protons plus neutrons. So if you knew the electrons, it is equal to the number of protons. So protons minus mass number minus protons will give you the neutron. So likewise we found, and I gave you all worksheets. I didn't get much of a good response, but I hope you all do do it and practice yourself. So next we are moving on to the periodic table, right? So we have 4 groups. It's okay. And 8 periods. 1, 2, 3, Lord. 5, 6, 7, and 8. That is a bit ugly. Let me draw it more neater. It's not neat now, but just saying. So we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, fluorescent. So these are the 20 elements. I'm sorry it's not neat, but yeah, so these are the 20 elements that we are learning. And these 3 elements were known as the noble gases. Why? Is because they have the electronic configuration of all maximum number of electrons in each energy level. Now again, what is energy level? KLMN. Okay, I'm just writing it so y'all remember. So now that is what. So even in the structure for helium, this is an helium atom. This is the nucleus, don't get confused. This is the first energy level and it has 2 electrons and the atomic number of helium is 2. So now this is, though it has only the energy level K, and K has maximum number of 2 electrons which it can hold. This holds 2, so this is known as stable. So because this is stable, I told you that these were the ones who were very satisfied with themselves. They don't want to become nobody else. They don't get involved in reactions. So they are stable and they don't get into reactions, which means we don't have to worry about it much. Likewise, neon will have 2 in K and 8 in L. So again, though this has 2 energy levels, 1 energy level more than helium, it still has its own respective maximum number of electrons in its energy levels. So therefore, this is also stable. So same way argon, it will have another energy level extra, but still it is stable. So this will be 2, 8, and this will also be 8. So again, argon is also stable. So helium, neon and argon are known as noble gases because they are stable because of this reason. Now that out of the way, we have 8 groups and they are the columns, right? And then you have the periods, they are the rows, right? You have 4 periods. Now first, if you're talking about groups, the groups tell you the number of electrons in the last energy level. Okay, so the number of electrons in the last energy levels, which means if you take any element in group 6, okay, then all the elements in group 6 will have 6 electrons in the last energy level. This last energy level can be anything. It could be K, it could be L, it could be M, but 6 will be the electrons in the last energy level for group 6 elements. Okay, so that is what you call group 6 or any group. Okay, so if you are taking a random element, let's take silicon. Silicon has atomic number 14, so its electronic configuration will be 284. So if you look at this 4 means number of electrons in the last energy shell. That is why it is in the group 4. See, silicon is in group 4. Okay, if you are drawing the structure of silicon, okay, 14 KLM 2 8 1 2 3 4 5 6 7 8 and 4 1 2 3 4. See, 1 2 3 4. That is the 4. That is group 4. If you take any element like that, whatever the group it is under, that group will have that particular number of electrons in its last energy level, no matter what the energy level is. It could be K, L, M or N. Okay, so that is the information we get through the groups. Now if you are talking about period will give you the information of number of energy levels for the element. If you take an element, that element, there is only 4 periods. So if you take any element, then that element will have either 1 or 2 or 3 or 4 energy levels only. So if you are taking oxygen, okay, oxygen has atomic number 8. Therefore, its electronic configuration is 2 6. So how many energy levels does it have? 2. That is why it is on the second period. And again, if you see, how many electrons does it has on the last energy shell? 6. That's why it has 6 electrons. If same thing, if you take sulfur is atomic number, how much? 19, 18, 16, right? 16. So electronic configuration is 2 8 6. How many energy levels? 3. That's why it is on the third period. What is the number of electrons in the last energy level? 6. That is why it's on the 6th group. So this is the relationship between groups and periods. Using this, you can place and position any electron in the periodic table. Okay. So noble gases are minding their business, but the others, okay, we're talking about the others. So let's randomly take an atomic number 11. Okay, we need to know what the element is. Okay, let's say So if it is atomic number 11, Z, what is Z? Atomic number symbol, right? So electronic configuration will be 281. So what is the group? What is the period? Period is 3. Why is it 3? Because it has 3 energy levels. What is the group? Group is 1. Why? Because there is only 1 electron in the last energy level. So group 1 period, group 1 period 3 is sodium. This element here. That is how you find and position elements. Okay. Okay, so the next thing we are going to talk about is the type of elements. Okay, whether is it a metal or is it a non-metal, okay, or is it a metalloid. Okay, so you all know the difference between these. We've learned this in previous grades. Metals conduct electricity. Okay, they are important in electrolysis. Okay, making electricity, all of that. Non-metals are important in other stuff. We need to know this. Okay, we will learn this in the next part. We'll learn about these elements later, but we need to know which are metals, which are non-metals, and which are metalloids. Okay, so which one of these is the metalloids? There is only one metalloids for your small periodic table, which is silicon. Okay, so that is easy. I'm going to take green and mark silicon as a metalloid. So metalloid means it has both properties of a metal and a non-metal. Okay, it can be both. That is only metalloids. Now non-metals, starting off with hydrogen, okay, and then you have it from boron, and goes on till fluorine, chlorine. Then silicon is out of the way. So yeah, okay. So these are your non-metals. So the pink is your non-metal. Oh, I'm sorry. Boron is also a metalloid. So you have two metalloids now. Two metalloids. And so if you look at the bigger periodic table, you will see that there is a step like this, the cutting the metals, metalloids and the non-metals. So it is orderly arranged. Understand? So these two are your metalloids. This is pink is your non-metals. So all of these are your non-metals, including this hydrogen here. He is a bit separated. And then you have your metals. Metals are the ones that are usually in abundant. but because this is a smaller one, you have only little. But if you see the bigger periodic table, you will understand that there are a lot of metals. Okay, so these are your metals, and the pink is your non-metals. Okay, so this is the classification of elements under whether it's a metal or a non-metal, or whether it's a metalloid. And this is also important, okay, to know if it's metals. And remember, metals are always solid, right, except mercury, for which is the only metal that is a liquid. That is all for this. The next part is, so you know how to divide your elements into the first period, second period, third period, fourth period, and the groups. And which group is called the group 0? Group 8, right? Because it's the normal gases. Okay. So you can read through the books, obviously. The next thing we're gonna learn is we already learned, revise, is the isotope. Now what on earth is an isotope? Remember, if you take an element, you have protons, neutrons, and electrons. Protons and neutrons, protons are always the same, right? Which means at no point do you want to change the number of protons, because if you try to bring out the protons from the nucleus, it will be an explosion, right? Then you have your electrons. Electrons are also constant in elemental state, right? So when it goes through a reaction, it can change. So mostly these two are equal, right? Protons and electrons are equal. Now when you talk about neutrons over here, neutrons can have varying numbers, right, which is called isotopes. Because if you take an element, they will have the same number of protons, they will have the same number of electrons, but different types of elements can have different do have different number of protons and electrons, right? Like no two element can have the same number of protons. These are unique to the element. This guy is also unique again when it is in the elemental state, right? But different elements can have different number of protons, which is why they are unique. Like I cannot have something that you have, okay, like features, because we are all unique, like fingerprints. I have a different fingerprint, you have a different fingerprint, all right. But neutron can vary. Yeah. So, and also, if you take an element, let's take element X, it can, let's say they have found out that it has only 4 isotopes. Then there is only 4 isotopes. With that said, let's say one has 2 neutrons, one has 3 neutrons, one has 4 neutrons, and the other one has 5 neutrons. Then this is the only thing that can exist. Alright, just because they have varying number of neutrons, it doesn't mean they can change any number of electrons. It doesn't mean they can add. It doesn't mean they can remove. They can't do that. If it is 2 neutrons, then it is only 2 neutrons. Okay? So that is known as isotopes. So again, coming back to mass number and atomic number and stuff. Now when you talk about, let's say this one has the atomic number 10. So atomic number is going here 10, and let's say 5. 5 is the neutron number. So if neutron number is 5 and proton number is 10, then your mass number will be 10 plus 5, which is 50. 50. Then for the other neutron, with the 4 neutrons, it will be neutron number X, atomic number 10, mass number 14. Then 10, atomic number 30. Then 10, atomic mass number 12. So these 4 are the isotopes of the element X. And this can only be the isotopes. There cannot be any other ones unless you scientifically find out. I told you how they find out. It's called, there is a big process, there's a big machine using these charge variations. They find it out. And yeah, so in all most elements have isotopes. So one that we learned was hydrogen, and they even named it. What were the names? Protium, deuterium, and tritium. So protium is because it has a mass number of 1, 2, and 3. Pro is 1, U is 2, right? And tri is 3. According to that, they have named it, and that is isotopes. Most of the elements have isotopes. Chlorine has 2 isotopes. Hydrogen has 3 isotopes. Likewise, they have a particular number of isotopes, and that can only be the isotopes that ever exist. Like how we saw that X has 4 isotopes, and hydrogen has 3 isotopes, and chlorine has 2 isotopes. This is the only thing that can ever exist. Alright, so that was isotopes. Okay, so the next thing that we started was the ionization energy. Okay, so because we left it in half, I'm ending the revision. So this was revision that we did all along, right? This was all stuff you know is done, and we spoke about all the stuffs that we just did. So with that, we can move on to the ionization energy part.